Hello everyone, in this video let's discuss about non-inverting summing amplifiers. So if you are new to our channel, don't forget to subscribe for more engineering related topics. So in this non-inverting summing amplifiers, we will be using the opamp, that is operational amplifier. So operational amplifier has two terminals, that is negative terminal and positive terminal. When you give the input to the negative terminal, it will be called as inverting summing amplifier. If you give to the positive terminal, then it will be called as non-inverting summing amplifier. So here we are giving the input to the positive terminal, therefore it is called as non-inverting summing amplifier. What does the summing amplifier do is, it will take more than one inputs and make the sum of the inputs and produce the output. Now we are discussing about the voltage. So it will take more than one voltage waves as the input and then make the sum of them and produce the output. So let's call it as V1 and V2. We are giving the input to positive terminal. The voltage across negative terminal as VA and voltage across positive terminal will be VB. So since it is producing the voltage V1 and V2 will be the inputs, so there will be the resistance for them. Therefore let's call it as R1 and R2. Now as voltage and resistance are present, there will be a production of the current. So let's call the current I1 and current I2. So these two currents I1 and I2 combinedly forms the total current I. So this current will flow from the input side and also in the feedback side. So in the feedback side we have RF. RF means resistance, that is feedback resistance. And this R represent the inverting terminal resistance. So negative means inverting terminal resistance. Then it will be connected to the ground. Ground means the ground voltage will be equal to 0. Since the current, that is the total current I, will not go through the terminals of the operational amplifier, therefore the current I value will be equal to 0. Now let's find I1 plus I2 value, as I is equal to I1 plus I2. I1 plus I2. So this process will happen at the input side or input end. Which is the input end? That is the positive terminal of the operational amplifier. So I1 plus I2 means now I must find the value of I1. So I1 is equal to, what is the Ohm's law says that? Ohm's law says V is equal to IR. So we want the current formula, that is I. Therefore V divided by R. So we must use I is equal to V divided by R. So I am considering the current I1. Therefore what is the voltage here? V1. So from V1 the current is traveling to VB. So VB is the positive terminal. So V1 to VB. V1 minus VB divided by, what is the resistance in between V1 and VB? That is R1. Next, what is the current I2? So current I2 value is, it is traveling from V2 to VB. So V2 minus VB divided by, what is the resistance in between those two? R2. So let's call this equation number 1 and let's call this equation number 2. So if you substitute equation number 1 in equation number 2, we will get the total current, that is I1 plus I2. What is the value of I1? Which is equal to V1 minus VB divided by R1. V1 minus VB divided by R1. Next plus V2 minus VB divided by R2. Now therefore the total current, how can we write? So I is equal to V1 by R1. Let's separate the denominator. So this is the common denominator, no? So V1 by R1 minus VB by R1 plus V2 by R2 minus VB by R2. Now we will combine the VB value. So we will send the VB to that side. So that side means left hand side. Therefore what will be the value? VB divided by R1. So as current value will be equal to 0, I already said total current value is equal to 0. So if it is 0 means, if we send this VB divided by R1 minus VB divided by R1 to this side means plus VB divided by R1, and minus VB divided by R2 if we send to left hand side means plus VB divided by R2, which is equal to V1 by R1 plus V2 by R2. So VB is common, so we can take VB as common. VB 1 by R1 plus 1 by R2, which is equal to V1 by R1 plus V2 by R2. Now if we take the LCM, that is VB into, what will be the LCM for R1 and R2? R1 R2. So here R2 plus R1, which will be equal to R2 V1 plus R1 V2 divided by LCM will be R1 into R2. So R1 R2 and R1 R2 will cancel out each other. So what will be left? VB into R2 plus R1, which will be equal to R2 V1 plus R1 V2. So if we send R2 plus R1 to this side, what will be the value of VB? VB is equal to R2 V1 plus R1 V2 divided by R2 plus R1. So this will be the value of VB, that is the input voltage, that is we are giving to the non-inverting terminal of the operational amplifiers. Let's call this as equation number 1. Let's design the output side equation. Output side equation. In output side equation, the same current is flowing. We will include both feedback circuit and the inverting terminal circuit. So therefore, first feedback circuit, the current is same. It is flowing between V out to VA. So V out minus VA divided by, what is the resistance in between them? RF. So which will be equal to V out, that is V out minus VA. What is the value of VA? VA value equal to VB value, as the voltage across the negative terminal of an operational amplifier will be equal to the positive terminal voltage of an operational amplifier. So VA value equal to VB value. We already know the VB value. So I will substitute VB instead of VA. As we know the VB value, we can do, so we can easily solve the problem. So we can separately write it as V out divided by RF minus VB divided by RF. Let's call it as equation number 2. Now for the inverting terminal, that is between VA and the ground. So what is the voltage? VA minus, it is going towards the ground. Ground voltage is 0. So the resistance between them is R. So VA divided by R. So VA value we don't know, but VB value is we know. So VB divided by R, as VA equal to VB. So let's call this as equation number 3. So left hand side of both the second and third equation is same. So let's equate 2 equal to 3. So left hand side is same, right hand side V out divided by RF minus VB divided by RF, which is equal to VB divided by R. So VB is there, I will take VB one side. So V out divided by RF, which will be equal to VB by R minus VB by RF. So let's take the LCM. V out divided by RF and VB will be common. So VB is common here. So 1 by R minus 1 by RF. How we can write? V out by RF will be equal to VB into, take the LCM, R into RF. So RF means it will go here, it will come here. So we have shifted the negative to right side, so it will be positive, it will be positive. So therefore RF plus R divided by R into RF. So RF in the right hand side and RF in the left hand side will cancel. So V out is equal to VB into RF plus R divided by R is left. We know the value of VB, so I will use it as the equation number 4. So I will keep VB one side and shift this full to left hand side, that is towards VO, that is V output. So this is in denominator, when it go to that side it will be of the numerator, R into V out divided by RF plus R. So this will be equation number 4. Now we know the equation number 1 and equation number 4. Both the equations have VB as the left hand side. So left hand side is VB in both equation number 1 and equation number 4. Now we can evaluate them. So first equation is R2 V1 divided by R2 plus R1 plus R1 V2 divided by R2 plus R1. As the denominator in the first equation is same, I am splitting, which will be equal to fourth equation. What is fourth equation? R into V output divided by RF plus R. I need the value of output voltage V0 or VO. So I will shift everything other than V out to the left hand side. So if I shift, RF plus R will come to numerator, RF plus R. Next R will come to denominator by R. So what will be left? V out will be left. R2 V1 divided by R2 plus R1 plus R1 V2 divided by R2 plus V1 is left. R2 plus R1 is left. If I multiply overall, what it will be? R2 into RF plus R. What it will be? R2 into RF plus R, and V1 is left, into V1 divided by R into R2 plus R1. R into R2 plus R1 plus multiply it to this one. So R1, write all the resistance first, then voltage. So R1, next it is multiplying with RF plus R into V2 divided by R into R2 plus R1, as R is multiplying to both. So what it will be? Which will be equal to output voltage VO. If in some certain conditions R2 value will be equal to R1 value will be equal to R value will be equal to RF value. If this condition satisfy, means all will cancel out each other and only the value will be left. What if the value will be left? V out is equal to V1 plus V2. So V out is equal to V1 plus V2. What it tells? The output voltage is the sum of the given input voltages, and here there is no negative sign. So if no negative sign means it is positive. What positive sign tells? Positive sign tells you have given the input to the positive terminal of the operational amplifier, that is non-inverting terminal, you have given the input. So this is the representation of the non-inverting summing amplifier. I hope you got the concept. If you like the video, please subscribe for more engineering related topics. Thank you.